Hello guys, it's Howard again. We are in lesson 4 of module 3 and we are going to look at the effects of water waves. Now, like I said, properties of waves including light and sound is our third module that we are continuing with, and today we're going to talk about the effects of water waves. General objectives: use water waves to show reflection, refraction, and diffraction of waves. Specific objectives: A. Learner should be able to demonstrate the formation of water waves. B. Perform an experiment to show the effect of depth on the speed of wave. C. They should be able to use a ripple tank to show and describe 1. Reflection of a plane surface. 2. Refraction due to a change of speed. And 3. Diffraction due to an obstacle or gap. Now, starting with water waves. One may ask, what type of waves travel through water? And the answer to that is both the longitudinal and transverse waves can travel through water. Both of them, both types of waves. Now let's demonstrate wave formation, starting with the transverse waves. These are drawn as a single continuous line, usually with a center line that we see here, showing the rest position or the undisturbed position. And then this would give rise to crests at the top and troughs at the bottom of the rest position or the undisturbed position. 2. The curves are drawn so that they are perpendicular to the direction of energy transfer. This is the direction of the energy transfer, and these lines are drawn perpendicular to that. And because of that, they then represent the troughs and the peaks or the crests of the transverse wave. Demonstrating waves continue with longitudinal waves. So longitudinal waves are drawn as vertical repeating lines, and usually some are close, like these ones at the beginning, which produce high pressure regions, which we call compressions, and the others are far apart, like these ones here, which produce a low pressure region, which we call a rarefaction. So high pressure regions are compressions and low pressure regions are rarefactions. Each point on the wave vibrates parallel to the direction of the wave. So when the wave moves that way, the vibration will also be in that direction. That is what we mean by that. 2. Let's look at the effects of water depth on speed of a wave. Now, water waves travel faster on the surface of deep waters than they do on shallow waters. Now, when we look at the diagram here, we have an end where there is a deep water and there is that other end with shallow water. So what we are saying is The change in speed of the wave will cause refraction as shown in the picture on the right. So this wave, as it moves from deep waters to shallow waters, its speed changes, and the speed changes such that it decreases, hence decreasing the wavelength of the wave moving from deep waters to shallow waters. So a water wave in shallow waters has got less speed, which causes the wavelength to decrease, and in deep waters it has high speed, which has a high or longer wavelength. Now let's look at reflection and refraction by a ripple tank. So the diagram here shows or demonstrates a ripple tank. So what is a ripple tank? A ripple tank is a glass-bottomed tank. This is the glass, and here is the bottom that we say is the glass-bottomed tank. And when we shine light from a lamp onto the glass which contains water, it produces bright and dim spots on a paper, on a screen below the tank, the glass bottom tank. So crest of waves will absorb more light than the trough of a wave. So crests appear as bright spots and troughs appear as dim spots as the water waves move through the ripple tank. Bright and dim spots moves as well, representing the wave that would be moving, that is produced using a ripple tank. We continue by how a ripple tank produces waves. Now, a ripple tank, you can produce straight waves, which has got plain wavefronts, straight vertical lines, and they are produced by using straight objects like a ruler or a pencil attached to the vibrator. And this is an example of the straight waves. These are the straight parallel lines we're talking about, which are produced by attaching a straight object on a vibrator to produce straight waves. Then we have circular waves, which has got circular wavefronts, which are produced by using a pointer object. Normally, the tip of a pencil is used, which is attached to the vibrator. And as that happens, circular wavefronts are produced because these are produced by a pointer object. So this is the difference, or the different waves that are produced in a ripple tank: straight wavefronts and curved wavefronts or circular wavefronts. Reflection of waves. A vertical surface is put on the path of the wave. The wave would then be reflected from the surface as at the same angle as they strike it. So what do we mean by this? Let's look at this diagram here. We have a wave that is produced that moves in that direction. And that wave, because it's our initial wave, we call that the incident wave. So this incident wave, if it hits a barrier at an angle, the incident wave would be reflected at the same angle as the incident wave. So then we get a reflected ray, which is produced by a wave that hits a barrier at an angle. And this is the ray diagram that we have. This is our incident ray, and this is our reflected ray. And if we draw a normal, we now have an incident angle and a reflected angle, and these two angles are always equal. Then the features of reflection: A, there is no change in frequency of the wave. The frequency of the incident wave is equal to the frequency of the reflected wave. B, there is no change in wavelength, so the wavelength from this peak to that peak is equal to the wavelength from that peak to that peak. C, there is no change in speed. The speed that the wave approaches the barrier is the same as the speed that the wave leaves the barrier. And then D, the direction of the wave travel changes. So this is the only thing that happens, because this was going that way. Now it changes directions and goes in that direction. Second, looking at the refraction of waves, and here we are on water waves. A flat piece of plastic makes the water shallower, which slows the wave down. What do we mean by that? If we look at when the wave slows, the change direction, the effect is called refraction. And this is what we mean by that. This would be deep waters, this would be shallow waters, this would be deep waters. So as this wave moves from deep waters to shallow waters, at that boundary, the wave would get refracted. And at that barrier again, the wave will also get refracted. So these are the features of refraction. A, no change in frequency of the wave. So as the wave changes, or as the wave is bent around different boundaries, the frequency remains the same. B, decrease in speed makes the wavefronts close on each other. That means if this moves at a particular speed, when it reaches here, the speed reduces, and as the speed reduces, it causes the wavefront also to reduce. C, hence according to wave equation, V equals to F lambda. As frequency remains constant, decrease in speed causes a decrease in wavelength. So it's only the speed and the wavelength that changes, the frequency remains the same. D, direction of wave travel changes unless they are traveling at right angles to the boundary. So because these are moving at an angle to the boundary, that's when refraction would occur. But if the boundary was straight in line with the wave, there would be reflection instead of refraction. And because now the wave would hit the barrier at 90 degrees, the refraction will also be 90 degrees from the barrier. And that is what we said in the beginning, that the angle of incidence should always be equal to the angle of refraction. Number 3, diffraction. Diffraction occurs when the wavelength of a wave is of similar size to an obstacle or a gap in a barrier. After diffraction, a wave will have the same speed, same frequency, and the same wavelength. And the diffraction of water waves. Water waves can diffract when passing through a gap in a harbor wall. The wavelength of the water waves may be several meters, and if the wavelength is of a similar size to a gap in a harbor wall, then the wave will diffract as shown on the diagram on the right. Now let's look at the diagram. Now we have two gaps that water will move through. If the gap is greater, there would be less diffraction at the ends of the wave. But if the gap is closer or smaller, there would be greater diffraction of the wave through that small gap. So because of that, we say these gaps causes the wave to diffract. So a larger gap will cause a smaller diffraction, and a smaller gap will cause a larger diffraction. So that is about diffraction and refraction and reflection of water waves. And that brings us to the end of our lesson. Thank you very much, and we will meet again in the lessons that are coming forth. Bye bye.